We're on part B, which is name the coordinates of 3 points that are inside the triangle. And so we're looking at the vertical line on -3 on the x-axis. And I'm going to pick the point -3, -2. I'm also going to go ahead and plot that point. Okay, now I have to come up with one more. I know that, again, there's only 2 points on perfect intersection, so I'm actually going to use a decimal. So I'm going to stay on my -3 line, and then halfway between -2 and -3 is -2.5. So that point would be plotted right here. Right? So you on your own, go ahead and do one more point on the inside of the circle. Pause the video. All right, let's go ahead and go over a couple of possibilities. Again, staying on the -3 line, you could have done -3, -3. You could have done -3, -3.5. And those 2 points would be here and here, respectively. All right, so let's go to C. What is the area of the triangle? Show your reasoning. Let's start off by writing our formula for area of a triangle. We know that area equals 1/2 base times height. Another easy way of doing this that I've seen a few of you do is base times height divided by 2. So let's figure that out. What would that be? I know that area equals my base. So I'm going to look at the bottom of my triangle and I see that it's 2 units across. So I'm going to take 2 multiplied by my height. I know my height has to be at a right angle to my base. So I'm going to count up 1, 2, 3 units. 3 times 2 divided by 2. And that's going to be 6 divided by 2, which is 3. So my area is 3 square units. All right, on to lesson 2. We're going to do both of these lessons today. This is on statistical questions. Go ahead and look at the bottom of your lesson 2 worksheet, and we're going to fill in some notes. Statistical question is a question that gives different answers that we can measure. So for example, how tall are you? That's going to be different because everybody's a different height. We can measure you using a yardstick or using a tape measure. What percentage did you get on the science test? Again, everybody's going to get different scores. We can measure those by doing how many questions you got correct out of how many total questions. If all answers are the same, it is not a statistical question. Everybody go ahead and underline this. If all answers are the same, it is not a statistical question. Number 1, look at the top of your sheet. 6th grade students were asked, what grade are you in? Explain why this is not a statistical question. We just took notes on this. I'm going to give you 30 seconds. Try to answer this question on your own. Go. Okay, hopefully the video is paused. Let's play it back. Here's what you should have said. This is not a statistical question because all answers would be the same. 6th grade. There is nothing to measure. Okay, let's look at number 2. Lynn and her friends went out for ice cream after school. The following questions came up during their trip. Select all the questions that are statistical questions. So because of this, I know I'm going to have more than one answer. Then I also want to explain any that are not statistical questions. How far are we from the ice cream shop? If you're with a group, are you going to be different distances or the same distance? It'll be the same distance. So I'm going to say for A that they're all the same distance away. If my answers are the same, is it a statistical question? No. So I'm going to cross off A. B, what is the most popular ice cream flavor this week? If I'm only asking about one ice cream flavor on 1 week, again, I'm going to have the same single answer. So can I show different answers? No. What does a group of 4 people typically spend on ice cream at this shop? Okay, now here, I can look at many different groups of 4 people, and I can figure out, okay, what do these 4 people spend? What do these 4 people spend? What do these 4 people spend? It's all going to be different, and then I can average them together. So this one is a statistical question. Do kids usually prefer to get a cup or a cone? What I would have to do is I would see how many kids got a cup, how many kids got a cone. Are those 2 different options? Yes. So that is a statistical question. How many toppings are there to choose from? All I would do here is I would count the toppings. There's just one answer. So this is not a statistical question. Here are a list of statistical questions about the students and teachers at a school. Select all the questions that are statistical questions. So for this one, I would like you to try answering these on your own. Pause the video and then look up when you're done, and we'll circle the ones that are and the ones that are not. This one is going to be one answer, one answer, one answer. Common age, many different ages. Hours of sleep, many different hours of sleep. How do students usually travel? Many different ways of traveling. 4. Here's a list of statistical questions. What data would you collect and analyze to answer each question? For numerical data, let's put a box around the root numer. Okay, we remember from earlier in this lesson that numer is a number. So above that, I want you to write number. For numerical data, numbers include the unit of measurement that you would use. So by unit, we're talking things like miles, centimeters, books, anything that follows a measurement, miles, centimeters, etc. So, A, what is a typical height of female athletes on a team in the most recent international sporting event? To answer this question, I would have to measure the height of many female athletes on many teams. Example, in the Olympics. This way I could see what is a common type of height. How could I measure people's height? I would probably want to use feet and inches. So for example, 5 feet, 9 inches. Are most adults in the school football fans? How could we answer that question? I'm thinking I could ask every adult if they are a football fan, and they would answer yes or no. Then I would see if there are more yeses than no answers. Okay, my unit would be yes or no. Okay, I want you to pause, try C on your own. Okay, let's talk about C. How long do drivers generally need to wait at a red light in Washington, D.C.? So this is asking about time. So if I'm going to measure time, I would have to time how long drivers wait at many different red lights in Washington, D.C. And then I would have to compare all of those measurements. So my unit, if I'm measuring in time, you don't wait at a light for hours. You don't even wait at a light necessarily for a full minute. So I would probably use seconds for this one. 5. Describe the scale you would use on the coordinate plane to plot each set of points. What value would you assign to each unit of the grid? Okay, so this is actually review. What we would do is we're not going to actually plot all these points. We're just going to think to ourselves, what would my scale be if I'm going to plot these points? So let's just look at this first example. I like to look at the biggest number and ask myself, what does my scale need to be to get to that number? So for A, the biggest number is 9. So I would have to go from 0 here in my y-axis all the way up to 9. Let's see if I can count by ones. 1, 2, 3, 4, 5. Can I count by ones? No. Let's see if I can count by twos. 2, 4, 6, 8, 10. Can I count by twos? Yeah, because then 9 is going to be right here. All of these other numbers have a smaller absolute value than 9, so I can plot all of them on this square grid. So my response to A would be scale would be 2. Okay, I'm going to jump down and do C, and I'm going to let you do B on your own. C is a little bit tricky because it is fractions. So I'm looking for my biggest fraction, which is actually going to be, there's two that are the same. -1 1/3 is the same as -4/3. So I need to get all the way to -1 1/3. So let's see if I can count by thirds. -1/3, -2/3, -1, -1 1/3. That's inside my grid still, so I know that I could count by 1/3. So I'm going to say here, scale 1/3. Okay, try B on your own, pause the video. Okay, let's talk about B. First step, I want to look for my number with the biggest absolute value, the farthest away from 0, and that's right here, -40. And so I want to think to myself, what scale do I need to create to where I can get to -40 and not have to go beyond my grid? So this is -40 in the x-axis, so I'm going to start here and I'm going to move left. See if I can count by fives. 5, 10, 15, 20, 25. Is that -40? No. If I can't count by 5, let's see if I can count by tens. -10, -20, -30, -40. Is that inside my grid? Yes. So what I would recommend for this is a scale of 10. Okay, 6 is also review. Noah's water bottle contains more than 1 quart of water, but less than 1.5 quarts. Let W be the amount of water in Noah's bottle in quarts. Select all the true statements. So this is written as an inequality. So I'm going to go ahead and write that inequality. I know that his bottle contains more than 1 quart of water. So if W is his bottle, I know that W has to be greater than 1 quart. So go ahead and write 1 quart is less than W, just like my paper. But W is less than 1.5 quarts. So I'm going to go like this and write 1 1/2 quarts. So I think the best strategy for this would be to draw a number line, because what we can do is we can come up with all of the values that are between 1 and 1.5. So I'm going to make this be 1. I'm going to make this be 1.5. And what I'm trying to do is figure out, could I plot these points that they're going to give me in between 1 and 1/2? Why or why not? Okay, A, W could be 3/4. 3/4 is less than 1, so A would be over here. Is that in my acceptable range? No. W could be 1. B would be right here on my 1 line, but the problem is that it doesn't say more than or equal to. It just says more than. So that's why I used a greater than symbol here.